Good day. Welcome to this IS Cubed X-Celerate webinar series. Today I will be introducing you to AVEVA's Operational Safety Management. My name is Jessica van Prince, a solution architect with IS Cubed. We see here how AVEVA's APM portfolio is continuing its acceleration to provide an integrated experience through a digital twin as an enabler for data sharing to drive customer outcomes. The foundation is provided by agnostic ability to access and manage all the information sources from clients' existing technologies on the plants as an input for the digital twin, supported by powerful and proven APM applications across the asset lifecycle and operational value chain. First is by setting the right asset strategy to optimize risk, cost, and performance towards the company targets and manage the regulatory compliance. Second, our large portfolio of analytical tools providing the right insight into asset health to match the asset criticality's impact on your company's targets. Thirdly is our prescriptive capabilities enabled by AVEVA's asset library as a digital link between knowledge share and client best practices that can be leveraged by the connected worker throughout AVEVA's digital asset maintenance solutions for more sustainable operations. In this full APM picture, AVEVA Connect's cloud portal is the fast track that will boost our solution delivery to our customer to ensure they deliver the customer targets. So now we're going to focus on AVEVA's operational safety management, which enables or helps you to improve safety and increase asset health and performance. So looking at what is operational safety management and giving you looking at the key business challenges that it does address. So operational safety management, or OSM, is a process by which maintenance activities or interventions are planned in detail. You specify the location, the work sequence, documentation, competencies required for the work to be done. Also looking at the risk assessments, what hazards has been identified together with the corresponding mitigations. And also the control measures, also authorized by technical and operational management, and the whole process gets documented in the solution. Then the work will then be done or executed inside the field, and then will be audited later on for safety and compliance reasons. OSM can also provide feedback to drive your continuous improvement to your EAM system. So when a work order has been completed, you can have the full line of sight of what is actually taking place. Moving on to the general or generic benefits of OSM. The first one is just utmost importance is the process safety. So this is to manage your operational activities and risk, identify simultaneous operations and avoid conflicts. So if you're doing hot work or doing work at height, to make sure that you don't plan or do work that might compromise the work that's being done on the same line or in the same area. Right? Also to ensure that you have your workforce engagement. This is for common situational awareness of activities and associated risk, and also drives the dialogue about the risk and mitigation methods and also the controls that's available. This is very important to ensure that everybody understands what needs to be done, and then and also ensures that if there's any issues that's identified, what's the mitigations to those risks that can be identified. Also in terms of the regulatory and corporate policy compliance to ensure that work is conducted in accordance with health and safety policies and standard, or also your SOPs, enable a full view or full visibility and approval of activities prior to execution. So you have a whole track record of from your planning phase of your job, and you can audit the whole all activities that has taken place, and you can based on what is your standardization or your SOP that's been followed to ensure that every step has been done for each and every task that needs to be completed. Also in terms of your production efficiency, this will also improve your planning and maintenance activities, and also to ensure that you don't have any disruptions to your operations, which can lead to cost implications. Going on and understanding the business context of OSM, so operating companies need to demonstrate regulatory compliance and a strong performance in EHS to maintain their license to operate and also to ensure shareholder loyalty. Organizations need to have effective process safety management and risk management policies to demonstrate that these are being actioned in the field, and the workforce is aging, and also the key skills that need to be transferred so the business don't lose out on that as well. And also financial constraints in both the CapEx and OpEx require ever-increasing efficiency and ability in the operations. And understanding the business problem. Maintenance activities are carried out on an asset to ensure that both safety and efficient to operate. Many of these maintenance activities themselves could carry risk to the safe operation of the plant, people's lives, and also the local environment, also the extended community in which your plant area is associated. So this is not only just about ensuring that you keep your people safe, but also the community that is around your facility. And also understanding the hazards associated with the work needs to be identified. The risk needs to be properly assessed, and the measures put in place to mitigate and control the risk prior to the work commencing. And the work needs to be in accordance with the company policies and best practices to the potential risk that's when you're conducting the work. And that's very important, is understanding the business problem that we address with the software. So process safety management that normally takes place on the site. So those two, and then also the compliant audits as well, is normally where operational safety management fits into that whole framework. Okay, just going on, just looking at the maintenance and work execution plan continuum. And so normally if the works don't get done daily, weekly, monthly, or quarterly, so the maintenance planner would normally review the maintenance backlog and then prioritize based on the criticality, safety criticality, and then also based on the production criticality, workload balances of resources, and all of this is normally been handled in terms of the high-level plan is normally done or managed in the EAM system, and then the weekly and daily tasks normally gets handled within the operational safety management system, or the previous name, which is software was known by, is control of work. All right, so then looking at dialing down into a 4-hour work execution. So let's say the maintenance coordinator imports the work into from the EAM system, generates the permits, then routes the permits to the SMA for assessment, and identifies all the isolations. The sub-manager would then review the permits and authorize the appropriately. So example could be cold work and vehicle entries, and then prepare the work plan for the planning meeting, and team review all the ongoing activities. So this normally falls in line with all the different activities that you're currently doing on site or the customers are doing, and you can see how this is relevant to the process safety activities that goes with your maintenance that you do perform, or any tasks that you need to do within your site. Right. Going on in terms of what the solution actually looks like, and giving you an overview of the different components or modules within the solution. Okay, so first I'm going to look at the high-level infrastructure of the solution. So OSM is a standard web application, and it requires an Oracle database to run. It's accessible from a browser on a client PC or through a Citrix connection. We support both Internet Explorer 11 and Chrome. And also in production environments, we recommend to separate the database and the web server on different servers. But both of these can be virtual as well. and there is documentation also available in terms of how you can set up or configure your implementation. And also, there's also template solutions descriptions which can be used in proposals as well. So if you're doing proposals to customers, you can also use that in the documentation. So we also have connection to SMTP server, so we can use for emailing, sending out emails, and that's essentially it. So it works like a standard, like I said, a web browser or web application. Okay, and then we also have integrations. So integrations normally happen from the web server side. We can also have the mobile application as well. We do the actual work order, actual lottery, tagging out and of your equipment, isolations. Then we also have external applications as well you can integrate with. And then we also have our own integration with the AVEVA Net to OSM. Okay, so looking at the different modules within the solution, there are some common functionalities that all modules have, and we call it the library list with extended search and filtering capabilities. You can add attachments to any module, like an instance of certificates or work descriptions to a work permit. And the solution also supports English by default and also Norwegian by default, but they can also be customized for any language. But as long as the work permits already support any language, there has been so far been no need to customize the language of the rest of the solution. But also we have customers in both Egypt and Indonesia, where we have used permit forms in the native language, and also events are logged and signatures are electronic, meaning auditors can go back and see everything which has happened during processing. You're also able to duplicate previous entities, which saves you a lot of time and reduces errors. And this is very handy when you need to plan for a repetitive maintenance task. The modules are linked together and use the business rules to ensure that you are not able to activate work permits if there are no linked isolations, which has not been approved. So you can't complete a work order a work permit if you have not, if there's an isolation that's been linked to it and it has not been approved. The workflow is highly configurable, which I will cover later on in more detail. So firstly, looking at the work orders. First looking at the homepage, So where all the modules can be accessed and where you can instantly start to create work permits, isolation lists, and etc. So this is also where you can access the user settings and also return to the homepage from anywhere by clicking the AVEVA logo on the top left corner. Secondly, we're going to go on to the work orders. So the work orders are automatically imported from an EAM system, and which can be Advantage, SAP, IBM Maximo, or others. And this is achieved by using an API that we offer, which can import the work orders on Excel or XML format, which is then shared from a shared folder where the customer will be able to export those files on a regular basis. You can also import the tag or functional locations in the same way. The solution supports hyperlinking from a work order in the EAM system directly into associates the work order within OSM, which is handy in terms of then creating a work permit, subject analysis, isolations, and risk assessments can be created from the work order page, resulting in them being linked together. Then we're going to move on to our work permits. So the work permits are configured from the client's original form, converted to PDF form, and linked to the database fields. Different rules can be configured to save time and ensure that all required fields are filled. Then plotting of the work locations is done on a plot plan. I'll focus on that a bit later on as well. Then moving on to the isolation plan. So the isolation plan is the work plan to ensure that certain work areas have been isolated from the other systems. For example, if the electricity has been turned off or the water has been shut off, so the work can be carried out. An isolation plan contains one or more isolation lists. An isolation list might include description of the work, the equipment, or the tag to be isolated. Optionally, you can also link a PNID documents where the equipment can be found. Also, the reason for the work, the purpose of the work, also the work steps within your isolation list, and also covering the risk and mitigations that is being addressed with the isolation. An isolation plan can then consist of any a combination of any of the electrical, mechanical, or heat trace isolation list. is a list of predetermined sets of steps that should be followed to isolate the system that will be worked on. A mechanical list can include PIDs documents which enable the user to graphically set the isolation points on points and also the order directly on the drawing. These PID documents can be either scanned, PDF'd, or hotspotted, or can also be intelligent drawings where a user can click on a valve or binding or blindings to create isolation points based on the information in the drawing. Okay, there's also a functionality of doing red marking on or annotations on a PID documents, which can then be stored in a separate layer. Then moving on to our installation list, it can be duplicated in case you are planning on routine maintenance or inspection jobs. This saves you time in preparing for isolations, and the user can be notified if there's a new version of the PID document, and will then only need to verify if the isolation points are still correct. Then moving on to our plot plans. So plot plans are 2D images of the work area or the site or the asset, which the planning when planning a work permit. The user will plot the location of the work on a plot plan image, and the image can be actively fed. Is automatically refreshed and enable the control room to have visual overview of the plan status at all times. The cross-section image can be added to visualize the whole asset when plotting a work permit on a plot plan. It will also be shown on the corresponding location in the cross-section image. Work permits are shown with different icons indicating the type of work permits and the status of those work permits, which makes it easy to, at a glance, to see an overview of the work going on or planned in an area or in a site as a whole. The information plot plans or IPPFs can be added to a plot plan at any time and include additional information not directly related to the work permits, but it can be a general information which the workers in the area should be aware of. After we've plotted our work on the plot plan, we then move on to our safe job analysis. So our safe job analysis is a procedure that integrates accepted safety practices into a particular task or job operation. It includes a set of questions or checklists which needs to be answered before a safe job analysis can be approved. The solution is delivered with a standard checklist which can be customized, and also the meetings regarding the safe job analysis can be recorded, and at least one meeting must be held before a safe job analysis is approved. So if no safe job analysis has been done, a work order cannot be implemented, or isolations cannot be implemented as well. The safe job analysis can be linked to work permit and business rules, can invoke to ensure that work cannot be started until the safe job analysis is imposed. So this can be part of your standard operating procedure, but they have to complete the safe job analysis before they start the work. Then moving on to our risk module. It's another way of assessing the risk before actually starting. So we'll ensure that we're assessing that the risk is acceptable to ensure safety for the operators, also the plant, also our environment, also our people in neighboring areas where the plant is located. So ensure that we have looked at all these different hazards, and it includes a configurable risk matrix, and the users will input tasks, their hazards, and which measures to take to reduce or remove the risk if it's possible. These will then be visualized in a risk matrix showing the initial risk and the residual risk after measures have been taken. Then after we've done the risk assessment, we will move on to our SIFT module. So a SIFT handover module enables logging of events during a shift, which will be handed over to the next shift. It includes different types of shift categories and event types which can be customized, and you can also reference the equipment or functional locations when logging these events. Then we can also then move on to our collections. Our collection module enables you to set up rules for executing of work permits. So like a maximum number of active permits or work permits cannot be activated before the previous permit is closed. Work permits can also be set to execute in a specific sequence. So before closing work permit, you can then do a lessons learned and link this to a work permit or equipment or functional location. This information can be used for knowledge sharing and information when performing similar tasks at a later stage. And then we're going to go over to our integrations. So integrations essentially will cover our put to SAP, maximal advantage of workmate. But now I just want to forget to that, just look at the mobile applications. So there are two mobile applications that's being used. So we have the work permit activator for activating permits in the field. Then we also have the isolation manager for isolation or de-isolations in the field. So lotto, de-lottoing, looking at that. And then we also have the external products that we can also integrate with. The integration is tightly with our AVEVA.net, where you can see your PID documents being handled in that situation or that integration. Then there's also being integration with AVEVA's mobile operator round is being developed, which will then import the log entries to the shift handover module within operational safety management. Okay, let's look at a sample process flow. Right, so this is just a sample process for a work permit. Right, the solution is delivered with a set of these, but they can be adapted to the client's process and part of the workshops which can be held in the beginning of the implementation of your project. So the work permit process flows always start with the applicant creating a work permit in the status new. The names of this can be, the statuses can be changed and usually are, and as well as a number of steps and the order of these. Some customers have very complicated processes, and additionally, the business rules, either standard or customized, can be invoked at certain points in the process. For examples of such cases is to ensure that the user has isolated the work site before starting on the work, or that the risk is managed properly. So this is the simple process flow, right? Okay, then moving on to giving you a more high-level view of how graphically how the system works together. So normally it starts with a work order coming from your EA system. You would then prepare the work permit. After you've done your work permit, you will do your plot your work location. You will then do your isolation list. After you've done your isolation stuff, if you will need supplementary forms, you can add your supplementary forms. You can do your risk analysis. You would evaluate your risk with the risk assessment. You would then start your work in progress with the lottoing. Then you would once the work is done, you would do your lottoing or de-isolation. And then you would then do your lessons learned and then close out your work procedure. This just gives you a graphical representation of what's a normal flow. Okay, moving on to the demo of the solution, just to give you an idea of how we would normally follow that same workflow that I just mentioned in the previous slide. So let's start. So the workflow starts off with the operator looking at a faulty heater in production. And after investigating, he already knows that the work order has already been placed in the system, and he proceeds to start the risk assessment to identify what the possible inspections for fixing the heater. When they are finished with the risk assessment, they will then start by creating a work permit to fix the heater if it's possible. They will then also create isolation. So based on all the information that's required, say that the bayonet heater inspection, we're giving a date time, is responsible for that. After we've done that, we're going into risk assessment. And then we're looking at the applicable risk. Then we specify different tasks that needs to be done. And then after we've done that, so we add all the individual component tasks that needs to be done, specify the hazards, if there's any hazards that are there, and then also the potential consequences. That's very important to add as well. Then if there's any mitigations we need to add, we'll add the mitigations, and then we'll just say if it's minor, major in terms of the risk, and then they'll also look at the residual risk as well. Then based on the scoring, we'll then decide to proceed with the job. Okay, so we have done that. We're going to then start with risk assessment. So we've done that. We saved it. Looking at the kernels, residual risk. So that is still within acceptable levels, even the residual as well. So we can see that's the task number. And then we can then say we're going to start the process, perform the process. Okay, so that is done. It can be approved. Risk assessment. Okay, that's done. So we're done with that. Okay, so now we're gonna start with the work permit. Then we create some work permit for the job. All right, so we'll then also, after we've done getting the work permit, we will then start looking at the isolations plan as well. So the work permit is customizable as well. So now we can look at where we're going to plot the actual work, where the actual work is going to take place. Right. So we're going to say that is on point A, and we're going to add it on our isolation list, plot the location. So the work order, we can see all the information such as the work permit, and then isolate, also the self-job analysis as well. So we'll finalize that, look at our isolations, we'll add the different isolations as required. So we're going to add a new isolation. So create an isolation plan for bayonet heater inspection, we add it in the title. Always note to make sure that you have the descriptive titles for your work that you want to do. Okay, we've done that. So the operator design the isolation plan by looking at engineering documentation, and also which topic involves the PNIDs to see where it's connected to. So based on all the information that you have in your PNID, you can decide in terms of upstream, downstream, what will affect your work that's been done. So that's why you create your isolation list. Okay, they start filling in the information needed for the isolation plan by including a brief description as well of the work to be done, the area and the system where the inspection will be executed, also a valid date, the range when the inspection will take place. The aim of the isolation procedure is to ensure that that accidental release of hazardous or energy does not occur, and to control all hazards to those doing the work. They proceed by adding a tag with the list as well, and the next step is just to create the isolation list. So this is where the operator defines the points and what type of isolation is needed. So the isolation plans consist of more than one isolation, since they make into the both mechanical list and also electrical list as well. Alright, so we'll see that in the points, open, close. So in this case, the operator will only need to add a mechanical list, as they only need to isolate the valves. To enter the isolation points, the operator can manually enter them, or they can use digitally interactive diagrams. And the heater tags can be found in the intelligent PNIDs. And then having a data management system, they can also be used in later revision of the PNIDs. They will then notify that the document is checked out for changes, and then they go ahead by selecting the valves around the heater. For each isolation point, they can then indicate the start position and maintenance being performed. Okay, so we've done the isolation list. Okay, we now added select the one we just created. Okay, so we've add. Okay, we're just reviewing it. Then we're gonna approve it. Okay, and the form there, we send it for approval. So then after it's been approved, so once reviewed, the maintenance manager will approve the isolation plan, and the operator will send a notification. Will also send the isolations as well before starting the inspection. So this whole workflow is then included in the system. So before the work commences, the maintenance manager ensures that all members of the work team are in agreement with the detail of the risk assessment as well as the proposed control measures. They then proceed to perform the isolation list, and at this point, the operator will now point to green and red labels to hand isolation equipment. They sign digitally after isolation that we completed, and the next technician will verify that the isolations are correct according to the plan and signs it digitally as well. And once the isolation has been completed, the technician activates the isolation list in the system, and now they can now they have the activated isolations and the next steps to approve and print the work permit or the work permit form for the work execution. They will also return to the work permit that was created in the previous section to submit it for approval as well. The level of approval must be corresponding to the level of risk. Higher risk requires more senior management approval, and these must be based on the initial risk. In this case, the work permit is reviewed by the permit authority to confirm all hazards and precautions have been identified. Once they have gathered all the required signatories, the work is approved. Okay, the last step remaining before the work can begin is to activate the work permit in the system. When the work has started, the control room operator can monitor the progress of the ongoing work and the work planned in the coming period. They can also view plot plans to see the graphical representation of all the plotted work by clicking on the individual plot points to show the information that each work permit when required maintenance work has been completed. So they only need to reset back the isolation once the work has been done. But before the isolation can be reset, the linked work permit needs to be completed. And the operator will complete the work permit to indicate that the inspection has been done or the work has been completed. Okay, so you can just see here, this is where you can see all the information about the work that's been done on the work permit. Okay. So the permit authority confirms that the site is left safe and tidy. So after the work has been completed, you specify that everything is safe, if it's been put in order, and they just need to reset the status by the isolation and for execution, right? So when everything has been confirmed, they reset all the isolation points in the area to conclude all the processes, and the last step is to verify the resets. So it's after the signatures, so we sign it. So all the multiple points, so we're resetting all of that, isolation points. So for this step, the technician proceeds to verify and reset after all the operator has finished resetting the isolations in the field. Once they complete the verification, they sign digitally in the system to indicate it's safe to open the restricted access. At this point, they have completed the isolations and can go back to normal operations. Right, so many of AVEVA's customers have found success throughout implementing the solution. And in this demonstration, I just showed you the high level, what it entails. So if you want to know more or get more information about the system, you can look at our website, www.iscubed.co.za, or if you want to book a session at our Customer Experience Center to experience our full-blown AVEVA portfolio, you can also get in contact with us on our website as well for more information. Thank you for joining me. Goodbye.